Okay, so we're going to finish up the last couple of examples. Example 2 says, show that triangle QPR is similar to triangle QTP. And so over here I have a right triangle QPR, right? This little symbol means right angle. And how do I show that? Well, we learned our new theorem today, angle, angle, right? So as long as we show that two angles are congruent, we can say the two triangles are similar by angle, angle, right? And so what I would do is, because they give us the similarity statement, QPR is similar to QTP, I would try to line it up because these lines right here are kind of hard to visualize. And what do I mean by line it up? So I'm going to draw a triangle QPR again without this extra line here. So let's draw that. So there's triangle QPR, right, without this extra line. And I want to show that similar to QTP. So QTP would look something like this. QTP, right? Notice everything is lined up, right? This first letter is lined up with this letter, second letter lined up with second letter, third letter lined up with third letter, right? R and P. Okay, so how do I show that they are similar? Well, notice angle T right here, right? In the diagram is given to you as a right angle, so you can mark that in your diagram. And so you can say, hey, look, angle P and angle T are congruent. You could say this is the right angle theorem. I'm running out of space here. You could say right angle theorem. And if you don't remember what that theorem states, basically it states that all right angles are congruent. Okay, so angle P is congruent to angle T by the right angle theorem. All right angles are congruent. And we need one more angle, right? And so over here, the last angle that has to be congruent is angle Q, right? This is the same angle. Angle Q is the top or the tip of the big triangle. It's also the top or the tip of the small triangle, right? QTP. So angle Q is congruent to itself. You could say angle Q is congruent to angle Q by the reflexive property. Okay, so if something is congruent to itself, you just say it's reflexive property. If right angles are congruent, you could say right angle theorem. Okay, so those are the explanations. And you could say, therefore, triangle QPR is similar to triangle QTP by angle, angle. Okay, so I'm running out of space here. I should have planned my showing the work a little bit better. Okay, so these two triangles are similar by angle, angle. You can see that these two angles are congruent. Okay. All right, moving on to example number 3 here. It says show that the two triangles are similar and write a similarity statement. Okay, so I picked two examples that are very, very common that you'll see in your textbook. And this time they don't give you a similarity statement. You're just going to have to somehow show and explain based on what you know about geometry. Okay, so the key piece of information here, right? We have two triangles over here in part A, is that these two lines are parallel, right? These arrow symbols indicate parallel lines. And whenever you have parallel lines, you want to think about your parallel line theorems. And the one that's most commonly used, right, is the alternate interior angle theorem. Okay, so if you don't remember what that is, I would recommend that you kind of look that up, or you can ask me later. So if this is my transversal, right, and I have two parallel lines, this angle right here has to be congruent to this angle right there. Okay, so you can say angle ABE is congruent to angle BED. And you can say by alt interior angle. ALT, INT, interior angles, by alternate interior angles. In fact, let me just erase that. That looks kind of sloppy. ALT, okay, alternate interior angles. All right, so I have two angles congruent right now, right? But I need one set of angles. I need two sets of angles, right, to prove that these two triangles are similar by angle, angle. I could also say, hey, this angle right here is congruent to this angle. So angle BAC is congruent to angle ADE. Also by alt interior angle. Okay, so I can say, therefore, triangle ABC is similar to triangle DEC by angle. Make sure you line everything up, right? So if I do double arc mark, single arc mark, no arc mark, I must go double arc mark, single arc mark, no arc mark. Okay, so I'm going to move on to the next example in the next video.